Hi there, this is Darren here and welcome to this course on G7 Natural Light, more specifically VM1. So we're going to go ahead and reuse a model that we've used a couple of times before now, and this is the model that was generated during the geometry residential course. We highly recommend that everyone undertakes that course because that course provides the foundations of learning pertaining to drawing and specification. There's also a secondary course around geometry commercial that is more about distributing information. But yeah, they would be a prerequisite for this course. Once you've done that, you can jump into this course and then we'll be able to start talking about G7. So let's go ahead and grab G7 for a second to contextualize it and make sure we're all on the same page in terms of what it represents. And here it is. So G7 Natural Light is I guess a standard verification method within the New Zealand Building Code, and it is provided through this document that you can see here, readily available on the MB website. Okay, so this document is the main parts of this document that are important from a modeling perspective is Appendix C, but there are other elements that need to be looked at, particularly in terms of the use of this verification method. So this verification method is deemed to be about natural light pertaining to habitable space, and those definitions are provided in section 1.2.2.1. Effectively, it provides you with a two-stroke methodology for undertaking an assessment using modeling. We use Radiance on the back end of the platform, and that means that you are using the most tested simulation engine for daylight distribution globally. When it comes to what you need to achieve in terms of G7 for these habitable spaces, strictly speaking, the demonstration of compliance is based on the lux level at the floor level, or the lux at the floor level for a percentage of the standard year. Now, that's deemed to be met by either A, under section 2.1.2, climate-based daylight modelling, or B, daylight factor modelling. The big difference between the two is that climate-based daylight modelling is a far more useful metric for looking at the distribution of daylight annually, where daylight factor is very much an old school method of pretty much doing back of envelope calculations to determine the whether sufficient levels of daylight have been achieved. And the sufficient values are dictated here in G7 as minimum daylight factor values. Okay, so these other values here, climate-based daylight modelling, this is more to do with the values stated here in the demonstration of compliance. And we can look at both, and indeed we may as well look at both because they may provide slightly different outcomes, although in our experience they equate to each other pretty accurately. So i.e. these values here seem to be in line with meeting these values, so there isn't a significant difference between the two methods here. But by the time you've selected that region, you've got your target value, your minimum daylight factor you need to meet, then you need to then go ahead and undertake computational modeling. That includes modeling the geometry and material reflectance and the visible light transmittance of glazing in order to look at these minimum levels of daylight. It's worth noting that unlike standard practice in daylight distribution, G7 Natural Light is more about the minimum required for safety. So this is not really looking at the quality of daylight across the space per se, it's more looking at the minimum required for safety. So this is a very different convention when it comes to daylight modeling. It's normally looking at quality of light, not minimum levels, but it is what it is. So As usual, within all modelling processes, there are strict rules that need to be applied, and these rules can and are met by the platform. And the crux of them are going to be in Appendix C. So I'm gonna leave some of the conversation here to the side in terms of other elements of VM1 that are really not important from a modeling point of view, and just jump straight into Appendix C. So as previously mentioned, C 1.1.1.1 provides the references to the climate-based daylight modeling and the daylight factor. By the time you get into the latter parts, we're looking at the simulation of specific elements, and it's just really providing a rule set or a set of assumptions around what is included, what isn't included. So internal details, this is probably the first one that is important from a method perspective. All internal partitions, fixed furniture and joinery elements that are permanent part of the internal area shall be included in the simulation. What does that mean? Well, it means that you've got to include things like kitchen benches, kitchen joinery, any other fixed furniture, and they would be excluded from the area that's required from a modelling point of view. So if you imagine that kitchen bench is sitting on the ground, then it makes sense that the ground that it's sitting on is no longer a part of this assessment. And that's kind of that's implied there, and it's also implied elsewhere. So we're going to go ahead and include some internal details in our model. External details, yeah, nothing really to write home about too much here, or at least talk to. These external details can all be included in your model, including overhangs, louvers, balconies, these types of things. For windows, skylights and openings in section C.2.4, yeah, you can go ahead and include the dimensions of windows and daylight openings to the nearest 10 millimeters as you require. And these should include the wall thicknesses, sills, projections, frames and mullions. Some of this is completely up to yourself as to how you draw these things. These provisions here, or these requirements, are getting into an extremely sort of detailed level of assessment that may mean that you have to spend more time on your model. They're generally not overly important, but it depends on how you're approaching your design. So it's completely up to you if you want to go ahead and start drawing these things in, but they are described as being required by C.2.4. Glazing visible admittance is required there, and you have some indicative glazing VLT values here. So the transmittance is, I'll show you where that's located on the front end. Reflectance factors, we'll get into that, but it's about distributing meaningful reflectance factors for your walls, your floors and your ceilings. Should you be in a concept, please go ahead and just assume medium reflectance values here. Should you be detailing things, then you're going to get these values from your materials and displace the values that are shown here on the screen. You are given some indicative values here that you could use as well if you don't have actual values available to you. Now, when it comes to the actual modeling itself, let's jump into this now. Climate-based daylight modeling is the dynamic modeling process that I spoke to in the introduction, and this is based on something called the CIE 110 overcast sky. This is just an overcast sky condition that is used typically in daylight modeling. And typically in daylight factor assessments, which is the non-dynamic assessment. When you're undertaking the climate-based daylight modeling, you'll be using the Perez all-weather sky model. And the modeling requirements are that the software used is tested to CIE 171. So Radiance has been tested independently through, believe it, through a PhD student, and we have that information available in our documentation. But CIE 171 is a very much antiquated, that was the word I was looking for, antiquated standard, which really hasn't been heavily adopted since the early 2000s. So that its reference here is almost a bit of a moot point, to be honest, but that won't be a moot point from a council perspective, because they'll still be expecting that this has been met, even though it's barely used in the testing world. So it's a bit of an oddity that it landed in G7, but it's here and it is what it is. So and I believe it comes from a reference in Singapore as to why it's kind of been adopted more locally here. But yeah, go ahead and check out our documentations. Just search for CIE 171 and you'll be able to get our reference to the testing undertaken on Radiance against this. Weather data, we use NEWA weather data, so we'll get into that. And when it comes to the simulation time step, i.e. the frequency in which we undertake the assessment, here we see a determination of a period between 8 AM and 5 PM on the 21st of each month of the standard year. So it's just giving us an idea of when the illuminance values shall be calculated, and then that means that the requirements right the way back up here at the beginning, and I am going all the way back for this, just so it's clear that these main requirements here can be met. Okay, so that's where that all comes back in. Okay, calculation grids, we'll get into those as well, but yeah, the calculation grids need to be set up in line with an external reference, ASNZS 1680.1, Appendix B2, and that provides some oddities, because it's saying that you have to have a very large boundary conditions in your grids, and I'll get to those when we set up the model as well. So that was all the climate-based daylight modeling, and then for the daylight factor, which is the the poor older cousin in daylight modeling simulations, you go ahead and use the overcast sky condition, and you have the grids determined as per the 1680.1 standard again, and then we have an equation there, simplified equation for the daylight factor. This is all kind of done for you, so you don't need to worry about that. And then the final step here is that you make sure, whichever you choose, you go through and provide a documentation of analysis based on these requirements here. And these, from a council perspective, are super important: the name of the modeler, the program used, your competency, the inputs, technical detail of the proposed building design, and the results of analysis to demonstrate compliance with G7. All of this is super important. We find that our documentation is generally well received, but the councils across New Zealand at the time of recording had a variable approach to accepting G7 VM1 simulations. Some happy to accept them, some seemingly to question them and push them into the PS1 land. Strictly speaking, from a code perspective, you do not need a producer statement to do this. You just need to be sure that you're illustrating that you have the competency and the understanding, and the further your documentation goes to show this, the easier it is going to be to demonstrate compliance against G7. Okay, so without much further ado, let's go ahead and specify this model to be more specific to G7. So there's a couple of things that we just went through there that we need to do, right? So first of all, the first thing we need to do is identify that we have habitable spaces that don't represent the entirety of the building. So we're going to use our tagging to distribute habitable spaces. Okay, so I've already got a tag there for habitable space. So I'm just going to select tag, and I'm going to select the 2 living spaces in the kitchen space, and we're going to nominate these as habitable spaces. These are the only spaces that we need to report on, including these 4 bedrooms. So these are all habitable spaces. Okay, that's all they are. Under my spaces, I've already connected that habitable space. I'm going to go ahead and delete that for a second and just connect up that tag that I just used, habitable, to this space type here. The reason I've done that is because I want that habitable reference outside the default space to be made available when I'm specifying. Let's go and have a look at the window systems. So in the window systems, we have variable window specifications in terms of the naming conventions. The specs all very similar. I've actually got a slightly different visible light transmittant for that one there. I'm going to leave this one here just to show that pop up there when we run our simulations. But effectively, you're going to want to nominate VLTs as per the specification provided by your suppliers, or use some relatively low VLT values as recommended within the G7 documentation if you're in the early concept. But a 0.6 shouldn't be a difficult value to achieve for most glazing options these days. Okay. Next up, let's go ahead and look at making sure that everything else is correct here in terms of our model. So we've got everything set up to run. I think we can probably start talking about running the model now. So we've got our habitable spaces, we've got our VLT set up in the model for our glazing systems. Next we can just go to daylight and go to the workflow itself, and we won't start running the simulation yet. I have our corridors next to a condition zone. I'll come back to that, or let me resolve that now. Now the reason that has come up there is because the habitable space is deemed to be a tempered space. I'm just going to put that, revert that away from tempered. Tempered means that the spaces around it are providing heating and coolth to it. So now I've saved that. That should disappear, and it has disappeared because I can see it's running its check now. And then I'm going to go ahead and go to our inputs. So we've got a scope, daylight factor, spatial daylight autonomy. That's what the G7 is requiring us to do. I'm going to reset these up so we can see these happen. Daylight factor, set this up again, G7 natural light, and we can see the 0.26, which was determined for Auckland. And we want to look at the total minimum of all zones. We're going to filter via space, and we're going to identify the habitable space, and then we've got the overcast sky conditions. So that recipe there, that soup of inputs, that provides the rule set to run your simulation. Go to spatial daylight autonomy, add SDA, G7 natural light, and again, effectively the soup of requirements as dictated by the G7 modeling method has all been set up for you, so you don't need to worry about it. There's 2 other things that you want to do here. Select habitable space, so we're going to again default to the habitable spaces only, not the entirety of the building. And then that calendar, we're going to update that to the 21st of each month instead, so get the simulations running much more quickly. So updating that, if that was all we needed to do, then that's all we would need to, would be finishing the process, but we're not quite there yet. So we're going to go ahead and start looking at grid settings, surfaces, and simulation settings. So first of all, grid settings, again, pretty easy, because from a G7 point of view, really, you model it on the ground plane. So at 0 plane height, the grid size is going to be 0.2. So quite a fine grid size. The grid source, we're going to be using a combined automatic and custom grid, and I'm going to come back to that now in a second. The automatic grid is set as a function of these boundary conditions. So the boundary conditions from the external envelope from the internal walls and any shading, including internal shading. So let's jump into this grid source because this is pretty important. And then the only final thing on the grid is the corners. Are they mitered? Are they rounded? And what color are they? Plasma is pretty, default to plasma. So let's now talk about the grid setting. So when we adopt a grid, typically, let's say the grid for this room here, we're going to get an offset from the external boundary lines here of 1 meter as per the conventions. There are some other conventions within G7 that allow us to, or to dictate that we need to model the furniture within the space and then create an offset from that furniture. So that's what I'm going to do here. I'm going to go to, first of all, I'm going to go to shading at the ground level and go ahead and select edit shading. And then I'm going to nominate shading by add horizontal shading here. And I'm just going to call that kitchen island and hit set. And then I'm going to come here and I'm just going to put this as whatever, kitchen bench or something like that, right? Kitchen bench. There we go. Okay, so they're now both in. And then what I'll do, I'm going to just change the color just so you know where to do that, should you want to do that, just for clarity. And then I'm going to extrude the height of that to 0.92. I think that's 920. I think that is a standard height for a kitchen island and a kitchen bench. I'm going to do the same for the bench here now, 0.92. So what that's done is that it's extruded that fixed furniture in place there. How do we know? Well, we can go to the 3D view and we can then go ahead and look at a view from this angle in order to determine that they are physically within the model. And this is something that is definitely of interest to councils. Okay, so now we're at that viewpoint there. We can go ahead and see the island bench and the kitchen there, and they are now included in your model, which will disclude the area beneath them. However, there's one more thing to talk about, and we'll need to navigate to daylight grid, where we're going to set up our own grid. Now, if we pop on the shading here, fundamentally the distance between here and here is less than 2 meters. So there is a rule set in G7 that in this case you must draw a set of grid points. Okay, and once you draw these set of grid points, we're going to be able to extract results from the length of this grid point here. So all I've done there is select add lines and do it like that, and I'm going to call this grid points 2. That's it, and hit set. And what that means is that we can combine the outputs from these grid points here with the automated output from the grid here that you can't visually see. But in other words, there is the automation is going to result in a grid reference, let's say like this, and that's going to be automated for you. And here we're going to draw them, and you're going to combine the two in order to show your results. So we don't need to draw the ones that are automated, of course, we only need to draw these ones. And now they're drawn, we can go back to the grid and make sure that combined automatic and custom grids are on. Next, in terms of the surfaces, so the reflectance of the internal surfaces, we have nominated values here, 60, 70 and 20 for walls, ceilings and roofs, and also one for the shading, reflectivity, external and internal. You can go ahead and nominate those as well as specularity and roughness. You may need to look at our documentation for more information on that. All you've got to do is just search for the word specularity or roughness and you'll find exactly what you want. This is for the whole building. So should you want to go ahead and be more specific, and let's say you had additional spaces for bedrooms, or actually let's just use habitable, and let's say the habitable spaces had floors that were really dark or something like that, or really light, something like that, then you would override the spaces associated to habitable with those inputs. Now, just to be 100% clear, in our model, we're talking about these spaces here. So it may actually make more sense for you to think about this in a different light. So let's say you had bedrooms. Okay, so we're going to create a pat tag for bedrooms instead, and you wanted to give those specific requirements. So I'm going to save those. I've got this tag for bedrooms now. That bedroom tag would then be available under a customized tag, and I'm going to set that for floors, and I'm just going to say that they've got carpets in them or something like that, and they happen to be represent this reflectance. Actually, let's say this reflectance here, much darker, and I save that. I've still got to make sure that those tags for the carpets are distributed, so I'm going to distribute those as well. So there you go, the tag for bedrooms, I should say, that allow the targets to be popped on. So here we can click and drag tags to change their priority. We'll have a higher priority than 2 when applied to the building. So that should be fine. And then I can bring those in like that. So it means that the carpets are going to be modeled separately. Might just pull those out of this one just to keep things cleaner in terms of the results. Almost there. So once that's all done, the last step is simulation settings. We suggest using a low setting to start with and a high setting as you get towards the end of your design process. Customization is very much in the realms of the PhD student, and you will want to really consider that very, very rarely, and only if you're very, very competent to do so. Otherwise, just choose low and take it from there. So I'm going to choose low and hit update and then rerun my simulation. Now, I had a test simulation ran there. I'm going to rerun this one now just to see how long it takes. The rule sets on simulations are pretty much run simulations for reduced time steps. So at 60 minutes rather than 15 minutes to start with. Run them on a low resolution radiance setting, so low rather than high, and see how long things take. This is effectively one of the quickest ways to get answers. Once you start increasing the time steps and increasing the resolution of the radiance settings, things are going to take significantly longer. So you'll find yourself, instead of running the simulation in the browser like I've just done, you're going to batch process it and save the simulations. So you're going to run it on our servers. It will be much faster over there, so you won't feel any impact on time, and you'll get an email once those simulations have been run. But it comes at the cost of a credit. Feel free to jump into our docs and look up the word credit to see what that means, but effectively that means it comes at a small additional cost because you're using that service. But in this case we don't need to, because the results have already come back. So let's go ahead and look at the results now. We're going to view them, and we can see, as always, the summary provides us with the first point of reference for the results, and it provides us, in this case, our acceptance criteria for both daylight factor and spatial daylight autonomy, whereby which we can see that 100% of the areas have been assessed, and the areas are the habitable spaces, and they, in both cases, they happen to be 1044 sensor points across 38.25 meters squared and 7 zones. Okay, so that's exactly the same in both. The difference in the rule sets are that this first one is for a daylight factor, so daylight factor is greater than 0.26 for 100% of these areas across the 7 zones, and that was 100% achieved. And the same is true for the spatial daylight autonomy, where across 100% of the total area, a greater lux value of 30 has been achieved for 75% of the hours between 8 a.m. and 5 p.m. on the 21st of each month. So they are both providing the same results. Now, if you're at this position here, great, but what you don't want to do is provide a report based on both of these results. You only need one of them because they both illustrate compliance with G7. So you're almost at the cutaway point where you say, okay, I'm going to show spatial daylight autonomy instead of daylight factor. That's generally a better way to do it because I think the rule set is clearer and there's a direct relevance to the stated method within G7 rather than just hitting the numbers over here that are determined on a climate basis perspective. So I have a preference for this, and daylight factor is not particularly useful in terms of a daylight metric, but that's another conversation altogether. Now, as we jump into these results, you'll see a plethora of inputs here, and there are lots of inputs. You can go through them elementally here under materials, grids, windows, important VLT values there. Skylights, that VLT value may be too high. A skylight is going to have a low G value or solar heat gain coefficient, and make sure that your climate data is kind of as expected. Once you're happy with all of those, then you can start to really contend with whether these inputs are correct, or sorry, the outputs are as expected is what I should be saying there. So to do so, you pick a winner. I'm going to pick daylight factor in this case, and we're going to go to building. So we can see our building results. They're not particularly easy to see here. I can turn some things off, shading. I could turn off the levels if I wanted to as well, but we can do that by just navigating to the levels here. So if I navigate to this level here, I also get the benefit of seeing the underlay, and that's really beneficial from a council perspective, so they can see this information. Now, you may even want to go ahead and copy this information into a report, into an email, into a presentation, so it's clear exactly what's going on. And probably the clearest you can be is if you switch to the top-down view here. You'll be able to, once set up correctly, you'll be able to see the grid daylight distribution across the grid plane with the numerical values representing each daylight grid point. In the case of the automatic grid here, and this is the grid that was created manually and brought in as a custom grid. So this is the reason why we brought it in here, because we need to see the data points all the way down through here to see what the minimum daylight factor is in these spaces here. Now this grid here can be updated in terms of how it's rendered, so you can go ahead and change which daylight factors are presented, so you can clamp them to values between 2 and 5, or even have it as 0 to 5, and if you update that, it's going to change the visual appearance of the colors on the grid. Another useful area is potentially looking at the point results here, so you can change the size of the point results. So I'm just going to change those to 8 and reduce the size of them there. And then what I might choose to do is I might choose to increase the frequency of them a little bit. Should you really want to have a lot more grid data points shown for the benefit of reviewers. Okay, so this allows you to go ahead and be really super specific. You could even just copy this directly into reports. Could do that. Let me go ahead and do it like this, so you could get the largest possible image and just copy this and bring this straight into your own report. That's one way of doing things. This will be provided in the downloadable report, but it's not at the same resolution, so this is slightly better, this method. You could also do something like this. So let's say you were to turn off all of this information here and just render this image here. So I've just turned off a bunch of information. I can even turn off those edges if I wanted to. Actually, I'll leave the edges on just for argument's sake. I'll turn off the grid. So let's say this is your final set of results. You could go ahead and then copy this and then bring this directly into your own PDF software and overlay it. And while this seems like a bit of a clunky work around here, it's not, because if you do this for 2 or 3 of your drawings and then include those within the report, that has far more punch with reviewers at council, because it allows them to fully understand that the modelling directly correlates with your drawings, and you can get a much higher resolution data set, and arguably for it's much clearer at that point. I'll leave that to your decision. Just bring everything back in here like this. And if you're happy with the way things are here, then yeah, you're kind of good to proceed with your production of the report. I'll just mention the spatial daylight autonomy as we have it here as well. So what we can see actually in both cases, the daylight factor and spatial daylight autonomy, is that you have your minimum, average and max values determined on a zone by zone basis. So you're able to articulate exactly where things are at from a design perspective. Arguably the daylight factor is probably the easiest one for people to see in terms of minimum values. So we had a minimum value of 0.26 for Auckland. It's 0.31 there. So you can see it's actually not that far from the minimum value, and that minimum value there is directly relating to that value that was on this grid here. So 0.32, 0.31, just there, that will be the minimum values there. Okay, so we can see that in the results. That makes sense. 0.31, there it is. So that's it. So once you're done, you are ready to go ahead and download the Radiance zip file. Should you be across Radiance, then you can see the exact input. So that provides you with a level of confidence that the modeling has been done correctly. We of course have deep Radiance assumptions here, which are not going to be useful for the vast majority of people, but they do provide a level of transparency. Everything can be copied out of the front end, so don't be afraid to copy this information out and bring this into your emails, into your reporting, into your presentations. And once you're ready to download, go ahead and just download the report, and that will be downloadable with your theme, with your branding, and with any information, additional information you want to pop in there. We strongly suggest that you use this opportunity to add additional information into your modelling, because this is where the council understand that you have understood the requirements of G7, and you have included all supplementary information that gives them the confidence that what you've provided is in line with the intent of G7. So you can go ahead and do that, and once you do, you hit create, and you'll get a report that's downloaded, which effectively is no different in terms of content than the summary here, with the only additional inputs into the report would be some overlays of the grid results that are presented here and here, but they're not particularly high resolution, and that's the reason why I was suggesting that grabbing the actual results is the better way to include them in the report by overlaying them onto the actual architectural drawings. That's it. Thanks a million for listening. Make sure you take the tests, illustrate your certificate of, or use your certificate of competency in your reporting, and maybe even in social media. You can download that once you're done. About 20 questions will follow. And thank you very much for listening.